The next part of our presentations is Climate and Extreme Weather Roundtable on how to manage some of these issues. We have Emily again. We have James Adkins, our Irrigation Engineer, Jarrod Adkins, our Extension Agronomist, Mark VanGessel, our Extension Weed Science Specialist, and Dave Marble Jr. from the Fruit and Vegetable Growers Association of Delaware. And I'm going to attempt something here. Hopefully it'll work. I'm going to try to pin each of you as you start talking. Each of you will have 5 minutes to give a summary of what you think the issues are and some of the management that you might go. So let's go with Emily first.
Okay, so Gordon already asked me to talk about sort of some of the issues that I saw. So I'm going to talk about some of the potential solutions to some of the issues that I talked about. Some other people might have some more issues to talk about. I'm going to talk specifically about variety improvement. So we have done a lot of variety trials recently, Gordon and I, looking to identify varieties that are more tolerant of heat stress. And we've looked at tomatoes, broccoli, cauliflower, Brussels sprouts, sweet corn, lettuce, tomatoes. I'm probably forgetting some. And I would say that one thing that I found really encouraging was that for many of those crops, we were able to identify varieties that did have increased heat tolerance. So on the snap bean, sweet corn, lettuce, broccoli, cauliflower front, we have been able to identify varieties that really seem to have heat tolerance that is a level of heat tolerance that will make them useful for helping us to avoid the sort of physiological disorders that we see that affect quality in those crops. Tomatoes, I would say, Gordon, that we're still looking for one that will do well, wouldn't you say?
We've got a one or two that are okay, but something with full heat tolerance, no.
And then for Lima beans, that is a major focus of my breeding program, is to select for heat tolerance. So trying to make progress on that for that crop as well. One thing that I've thought about related to both the sort of overall tolerance of environmental stresses is trying to look for varieties with good root health. So for peas and snap beans, that we are susceptible to a lot of root diseases. In some of the cucurbit crops, we have a lot of root disease susceptibility too. Trying to really manage those root diseases or use varieties that are resistant to root diseases are going to help the plants tolerate both stress from drought and heat, which are related stressors. So drought stress is going to exacerbate heat stress and make it even more damaging. So as a corollary, that tolerance to drought, like in addition to better root health, there are some varieties that are better at managing their water status. Their photosynthesis is more heat tolerant and more heat adapted. They're just better at managing plant water. So those are more drought tolerant varieties. Trying to identify those varieties that will help us deal with unpredictable environmental stresses is also important. And then obviously other foliar diseases, when we have increased leaf wetness, just trying to choose varieties that have good resistance or tolerance to the diseases that we expect to see. That disease resistance is not always available, or not always available in the varieties that we want to grow. So then, but where it's available, we should be trying to use that. And then I think it'll be important to even more important to look at performance of varieties across years and across regions to choose those that are adapted to a wide range of environments, so that because we aren't really able to know what the season is going to bring us, and maybe even less so in future years. So breeders are already trying to select those varieties that perform well over years and in different environments, but we should be looking at variety trial information and assessing it in that way, not just the variety that is the standout for that particular year. I think that's pretty much what I have to say.
All right. Thank you, Emily. James?
Okay, good morning, everybody. Comes to mind in all this discussion, something I was told 20 years ago from a farmer that basically told me irrigation should be secondary to drainage. So drainage first, irrigation second. And I think collectively, I'm guilty myself of looking at the irrigation design considerations primarily, and then drainage as a secondary. As our fall has proven, we need to be thinking about drainage before we even plant. Some of that is going to be reflected in where you're located. I come from an area that's heavily ditched, and it makes it a little easier. But most of our vegetable production is in areas that does not have ditches in a regular interval, and you have these pothole situations. So we see growers every spring in a vegetable scenario in a panic to try and drain a pothole in the middle of a field, trying to save the crop in that spot, number one, but number two, trying to prevent the disease. So some planning ahead of time can facilitate that. Number one, putting in drainage trenches or even tile lines to those holes. We know where the problems are from experience, number one. And number two, the Google Earth images and other sources for satellite imagery gives us a very good definition of where our problem spots are. In this age of data being generated from auto steer systems, et cetera, it's not a problem to have an elevation map either from existing data, planting data, harvest data, or be generated fairly straightforward if you don't have access to that technology. It can be done very quickly now versus bringing a survey crew out and trying to do it like we used to have to do. One of the things I see more often than not is plastic is laid where it's most convenient for field operations, which sometimes means we bed up plastic that is going to interfere with the natural surface flow of a field. So we're blocking that with a bed. There's going to be cases where we need to really rethink how we do those field operations, and maybe it's not as convenient for field operations in order to accommodate drainage. Perhaps breaking a row of plastic in order to accommodate a trench like they do sometimes in tomato production to allow that water to get out if we're not able to put a tile line or a riser or something in before. The other piece would be creating sumps for lift pumps. And we see folks all the time using trash pumps to try and pump water off fields. It's a labor intensive operation. One of the things to think about ahead of time is your fuel tank size. I hear guys getting pumps set up, but you're spending the entire night refilling the fuel tank every 2 hours in order to keep that thing maintained. It's easy to adapt a boat tank or something like that to a trash pump in order to get a little more length of run time. We are using electric pumps. It's not anything new for lift stations. It takes quite a bit of engineering and design ahead of time. And that's something we collectively need to be thinking about, is laying these systems out to correct our problems well ahead of time. We all need to get more familiar with using lasers and other technology in order to lay this stuff in line, because let's face it, the installation of a tile drainage system, a tile riser, can get expensive if you're doing it with a contractor. Most farmers have the ability to get this kind of stuff in, get it in well, particularly if they have experience and knowledge and the investment in a cheap laser system to help them guide the grades and whatnot. All this kind of comes back around into how we design irrigation systems. The notion that a center pivot is most efficient when we're applying water on drops with a very narrow radius is something that works well in the western states, but does not translate well to the East Coast, simply because the evaporation loss isn't our primary concern. Keeping that water on target so we're not flooding holes is going to be the biggest concern that I have. And that's easiest done with overhead sprinklers with the maximum wetted diameter we can find, which ironically is going to be your high pressure impacts and your impact sprinklers, which have been discouraged for the past 20 plus years for more energy efficient sprinkler types. So we've got a juxtaposition between energy efficiency and water use efficiency. The farther we can throw the water with the sprinkler system, the more likely it's going to stay on target. And we see this regularly with water running down planted rows, planter tracks, beds, and saturating the holes where we already know we don't want any irrigation to be applied. And then we're losing that water that we wanted on that hill. So some sprinkler systems to maximize wetted diameter is going to be our first thing. Are we talking about going into variable rate application? Traditionally, the numbers don't work out for most of Delmarva farms on agronomic crops, but on high value vegetable crops, there may be some opportunity there to do a better job as far as efficiently placing water where it's needed. Number one, to allow us to irrigate those areas that get water stressed early without having a negative effect on the lower ground. We're seeing this being adopted a little bit in the sod industry, just because it's a high value crop and it's very negatively affected by excess water as well as too little. And maybe this needs to do some new calculations to see where this works on vegetable crops particularly. When it comes to drip design, there may be some opportunities to evolve how we're running drip lines to do the same thing in a net benefit to our higher areas versus our low. But just thinking about the drainage and the combination of drainage and irrigation ahead of planning rather than after we've laid the field out to maximize our opportunity there to take advantage of both tools. One other ancillary thing Gordon asked me to mention, and I'm a little bit uncomfortable with that, is using irrigation as a tool to cool plants, particularly in the evening. I don't know that the data is out there to support exactly how much, and whether it's a net benefit or not. I do know there are industries, ag industries, that are using irrigation to, particularly in the morning after a dew, to reduce disease. And the concept is that our diseases have multiplied overnight in that vegetative wetting, and that by irrigating first thing in the morning, you can rinse that off, and that inoculum is not staying on the leaf. How that translates to the vegetable industry needs some research, and I think that's something we can work on going forward.
Okay, thank you much, James. Jarrod, I think I introduced you as James's brother before, so it's Jarrod Miller, not Adkins. So
that's all right. So I deal a lot more with agronomic crops, obviously, but there is some overlap with what you guys would see. I end up doing some research with saltwater intrusion along Delmarva. So we'll have being on the East Coast, we're going to have issues that some other people don't, particularly if you're along the coastline, because with the rising sea level, we end up having two problems. One is with hurricanes or just the rising tides coming in, more salt water is coming up on our land and leaving salts behind. When you're out west, the kind of issues they have with salts deal a lot more with, they have excessive evaporation bringing salts up, or it comes in with their irrigation and it doesn't leach through. Typically in this region, when you get 40 to 80 inches of rainfall a year, even if you added some salt, say from some wastewater, you can wash it through. And our problem comes back to what James was talking about with drainage. These lands are already very low. They have very high water tables. They're right along the coast. There's not a whole lot you can do to improve drainage unless you've never had any drainage ditches at all. You can try to prevent the tides from coming in. Like in Somerset County, Maryland, they have they put tide gates in to try to keep the water from coming up their ditches, because some of these ditches drain right off of there. But once the salt gets on this land, we can't use, in some cases, some of the methods to get rid of the salt. So excess sodium is one thing. It's toxic to your plant roots. Excess sodium is going to give you issues with soil quality as well as plant growth. And the typical remedy is to add gypsum, but salt water also has calcium, magnesium, sulfur, and chloride. It has all these other salts in it, and gypsum is a calcium sulfate. So if you have excess sodium, gypsum can help. If you have excess calcium and magnesium, gypsum is just going to add to the problem. And if you have poor drainage, then you're not going to get those salts out. So in some of these cases, this land along the coast can be remediated if you can drain it, if you can add gypsum. In other cases, we're just gonna lose that land. And the other problem is, if you've ever looked at how groundwater works and how the way salt water comes in with the groundwater, as sea level rises, it's going to push underneath in our groundwater more of these salts into the groundwater. So then the water from, say, your irrigation from either groundwater or even some of these ponds, then you start adding salts to your soils. So if you're upland enough, maybe the salts are low enough in concentration, you just let rainfall assist you in washing that out of the root zone. But if you're in a bad spot, it's going to keep adding salts to that soil. So our problem, and we're still doing research and trying to figure out how to do this, you can rotate in crops that are more salt tolerant. There are things like we've talked about asparagus. I don't know how much asparagus is grown in this region, but asparagus is one. We've mentioned things like quinoa. So, and certainly row crops like barley and wheat and maybe a salt tolerant soybean and sorghum work better than corn in those instances. Or having pasture or grassland. I know out west in South Dakota, though, they will actually grow barley year round as a forage as a way to deal with some other saline land. So there might be some ways to rotate crops in there, but in some cases, we're not going to be able to solve that issue. Some of the other stuff that I've seen, again, it's more with agronomic crops, is particularly with nitrogen cycling in crop growth. So if you put, say, cover crops in some of these fields, or you rotate in some small grains, some of this warmer weather has been a good thing. It used to be, I tell people in November, if you start to plant a small grain, you're really cutting it close to hitting a freeze, but we haven't been seeing that as often. And you can sometimes plant in the beginning of November and still get a stand that's not even knocked out with a light freeze. The opposite side of that is we end up getting excessive tillering and a lot of excessive growth. And it's been hard to figure out, particularly last year, how growing degree days match up with some of these small grains that we're growing. And then when do you apply that nitrogen? Like in some cases, we were running out of nitrogen in February last year in some of our fields. And the regulatory environment in this area with the Bay is that in most cases, we restrict people until March 1st with any additional nutrient applications with nitrogen. And we've had to work with state departments to get out and say people can apply earlier because some of this weather is messing with growth in the fall. And as we saw in Kevin's presentation coming with nitrogen, there's a lot of discussion about these very high rainfall events coming through. And we saw it in 2018. So it's good that Kevin isn't seeing it here. So it's very helpful to me to know that isn't happening, but still we have those events anyway. And if they come down the road, if we end up getting excessive rainfall in the area, you get 2018 where all the questions from everybody was, where's my nitrogen at in these fields? And the answer was, we didn't know, because field to field, spot to spot, whether you had leaching from that rainfall or whether you had denitrification, it was just hard to tell without soil tests. And then having that drainage, like James mentioned, and getting the water off is the best case to make sure that you have that nitrogen. There could be one possible benefit if you're a soybean grower or a corn grower, that if we're having earlier freezes, then that opens up a longer growing season for some of these crops. But still, the land can be so wet in these areas. And I should mention that saltwater intrusion, that 50% of the problem is really moisture. Even if you don't have salt come on the land, with high rainfall, if you don't have good drainage because sea level's higher, we have moisture sitting there and you plant the seeds and they rot in the ground. So that's a lot of more of what I'm seeing along the agronomic crops. It can overlap, I guess, if people rotate them in or they also plant vegetable crops on those lands.
Well, thank you, Jarrod. Our next panelist is Mark VanGessel, our Extension Weed Specialist.
All right. Thank you, Gordon. So what I'm going to do is talk about some of the things that I don't have a lot of data to support, but some of the things we're seeing now as it relates to climate and weeds, and as well as some things that might be more speculative that might be coming or things at least to be aware of and things to take under consideration. So given some of the different things that are rolled into this topic of climate change and extreme weather and all, one of the things that we're seeing is obviously and Kevin talked a lot about this, was milder winters. And I think we are seeing this already impacting our winter annual weeds, that we're just not getting that period of time in January, February that's just shutting down weed growth. And so when we're coming into the spring, whether it's trying to control weeds in small grains, or burning down fields before planting, or even trying to work our ground if we're in conventional tillage, there's a lot more weed biomass out there than we typically would have seen. So that's one thing that's associated, and I think we are seeing that now. The other is the increased likelihood of some of these cover crops